What is momentum? Momentum is inertia for moving stuff. So remember, inertia is an object's resistance to a change in motion. And how do we measure inertia? This is massively important to understand this. Inertia is measured in mass. So remember, the more mass you have, the more inertia you have. Well, momentum is inertia for moving stuff. So momentum describes a resistance to a change in motion for moving stuff. Momentum is represented by the letter P. A lowercase p, even though you can't really tell it's lowercase, momentum is represented by a lowercase p. Momentum is equal to mass times velocity. So the m is mass, the v is velocity. So what does momentum involve? Momentum involves mass and it involves velocity. If you have mass and you are moving, then you have momentum. If you have mass but you're not moving, like me right now, then you have zero momentum.
See, I have zero momentum because I'm not moving.
If you do have momentum, that means you have mass and that you have a velocity. The more mass you have, the more momentum you have, the more velocity you have. The faster you're moving, the more momentum you have. So I said the faster you're moving, the more momentum you have. What does that mean, like conceptually? The more momentum you have, the harder it is to change your motion. So let's talk about me moving fast versus me moving slow. If we're talking about me moving fast and me moving slow, we're talking about the same object, me, and I have the same mass. But if I'm moving slow, then I have less momentum. If I'm moving fast, then I have more momentum. What does that mean conceptually? Well, if I am moving slower, I have less momentum, which means it is easier to change my motion. If I'm moving slow, it is easier for me to accelerate, to speed up, or to slow down. If I am moving fast and I have a lot of momentum, it is going to be very difficult to change my motion. It's going to be very difficult to make me go even faster or to slow down. So I like to think of it in terms of like running, like when you're running on a track. So just think about it like if you're running. So if you're running at a slow medium pace and you have to speed up, then that's possible. Like it'll require some effort, but you can speed up and start sprinting, right? But what if you're running at like your max, so you're sprinting super fast? It's gonna be way harder to speed up if you're already sprinting super fast. If you're already moving super fast, it's gonna be way harder to move even faster because you're already moving super fast. In terms of momentum, if you're moving really fast, you have a lot of momentum, so you have a high resistance to a change in motion, which is why it's harder to go even faster when you're already moving super fast. So we talked about how speed affects momentum. How does mass relate to momentum? Okay, let's say that you have a huge big rig, like a huge 18-wheeler truck on the freeway, moving 60 miles an hour. And then you have a motorcycle on the freeway also moving 60 miles an hour. Okay? So both the big rig and the motorcycle have the same velocity. They're moving at the same speed in the same direction. So what's the difference? The big rig and the motorcycle have different masses. The big rig has a lot more mass than the motorcycle. So then which one has more momentum? They're both moving at the same speed, and the big rig has more mass, then it has more momentum. The big rig has more momentum because it has more mass. So what if there's traffic and the vehicles need to brake and come to a stop? Which one's going to have a harder time doing that, the motorcycle or the big rig? It's going to be a lot harder for the big rig to come to a stop compared to the motorcycle. The motorcycle will hit on the brakes and it's going to very quickly come to a stop. Now the big rig, on the other hand, is going to take a longer time, it's going to take a longer distance, it's going to be a lot harder for the big rig to come to a stop. Why is that if both the big rig and the motorcycle were moving at the same speed? The difference is the big rig has more momentum. The big rig has more mass, more momentum at the beginning. The more momentum you have, the harder it is to change your motion. And so it was much harder to change the big rig's motion to make it come to a stop compared to the motorcycle because the big rig had more momentum. momentum is a vector, right? Momentum involves velocity. Velocity is a vector, which means momentum is a vector. Momentum has direction. So if I call that way positive and that way negative, right? If I move in the negative direction, I have negative momentum. If I move in the positive direction, I have positive momentum. So you can have positive momentum and you can have negative momentum. So the direction of momentum matters.
Momentum has a direction.
Don't stop watching yet. We've built up a lot of momentum here to get to the main idea. If there are no outside forces acting on a system, momentum is conserved for the system. Momentum is conserved. Now give yourself a moment and think about it. So when we're saying momentum's conserved for a system, we first have to determine what is our system. You have to decide which objects are a part of the system that you're going to be talking about. So in this me and skateboard example, our system includes two things, me and the skateboard. Me and the skateboard are both part of the same system. What does momentum being conserved even mean? It means that the total momentum of the system at any point is the same. The total momentum for the system never changes. Again, that's true if there are no outside forces acting on the system. So as I'm riding the skateboard, it's me and the skateboard, and there's no other outside forces changing our momentum. If someone were to run into me and push me off my skateboard, or give me a push to speed me up on my skateboard, that would be an outside force because that other person is not part of the system that we were talking about. Remember, the system is just me and the skateboard. I'm going to show you how momentum is conserved for me and the skateboard as a system. My skateboard is going to be at rest on the ground, not moving, and I'm going to run and jump onto it. Okay? Then I'm going to ride on my skateboard for a while, and then I'm going to jump off the back end of the skateboard. Let's see what happens. In advance, I can tell you that momentum is going to be conserved for the system of me and the skateboard the whole time. So whatever momentum the system starts with, the initial momentum of the system, that's going to stay the momentum of the system throughout the entire motion because momentum for the system is conserved. So for this me skateboard example, to get the total momentum of the system, we are talking about adding together the momenta or the momentum of all of the different parts of the system. So I want to know, what is the initial momentum of the system? What momentum does the system have at the beginning? So if me and the skateboard are a system, to get the total momentum of the system, we have to add my momentum and the skateboard's momentum together. Remember, we're talking about both me and the skateboard in the system. So for the total momentum at the beginning, the initial momentum, we have to take into account the momentum of all of the different parts of the system. So we have to think about my momentum and the skateboard's momentum at the beginning for the total momentum of the system at the beginning. So let's talk about the momentum of the system and of the different components of the system before I jump onto the skateboard, when I'm on the skateboard, and after I jump off. Okay, so at the beginning, did I have momentum? I have mass, and I had a velocity. I was moving. So yes, I had momentum at the beginning. Let's say that I had a momentum of 10. Just my momentum equals 10. Did the skateboard have momentum at the beginning? The skateboard has mass, yes, but it was not moving at the beginning. It had no velocity. So at the beginning, the skateboard had 0 momentum, and I was the only one who had momentum. The total momentum of the system, we would add the momenta of me plus the skateboard to give us a total momentum of 10. Because momentum for the system is conserved, the momentum of the system is always going to add up to 10. So what happened when I jumped onto my skateboard? Well, I jumped onto the skateboard and the skateboard started moving. And I kept moving with the skateboard. The key here is that the skateboard started moving. What does that mean? The skateboard gained momentum. So after I jumped onto the skateboard started moving, so the skateboard gained momentum. What about me? Do I still have momentum? Yeah, I still had momentum because I was moving with the skateboard. Wait, did that mean that we just like gained momentum out of nowhere if I still have momentum but the skateboard just gained momentum? No. If you look closely, when I jump onto the skateboard, I slow down. So the second that my feet land on the board and the skateboard starts moving, my speed slows down and the skateboard's speed goes up. So I was running at the beginning, I had a certain speed, a certain velocity. The second that I landed on the skateboard, my speed, my momentum decreased, but the skateboard's momentum increased. And that's where you get conservation of momentum. So I slowed down, I lost momentum, I gave that momentum to the skateboard, which is why the skateboard started moving and gained momentum. Did we lose any momentum? No, momentum was still conserved for the system. Part of my momentum went to the skateboard, but me and the skateboard are part of the same system, so the total momentum of the system stayed the same. What is the total momentum of the system? At the beginning, the total momentum of the system was 10 because I was the only one who had momentum and I had a momentum of 10. Once I jumped and landed on the skateboard, the total momentum of the system is still 10, but now I'm not the only one who has the momentum. The momentum of the system is split between me and the skateboard. So do me and the skateboard have the exact same momentum when we're moving together? Like, is it 5 and 5 or 7 and 3, like 9 and 1? Like, who has more momentum? Or did the momentum split equally between us? Me and the skateboard are moving at the same speed, right? I'm on the skateboard, I'm moving with the skateboard, so we're moving at the same speed. Remember, momentum's not only about speed, it's about mass. Me and the skateboard have different masses. I have more mass than the skateboard. If our speeds are the same, but I have more mass, that means that I have more momentum, right? So the momentum split might be 6 and 4, or maybe 7 and 3. So if the total momentum's 10, I will have more of the momentum because I have more mass and we're both moving at the same speed. So I might have a momentum of 7, for instance, and the skateboard might have a momentum of 3. And so I have more momentum because we are moving at the same speed, but I have more mass, so I have more of the momentum. What is our total momentum of the system? It is 10. I add 7 and 3. Okay, so then I was riding my skateboard and then I jumped off the back of the skateboard to a stop. I came to a halt. What happened to the skateboard? The skateboard shot out that way in front of me at a very fast speed. Why? Well, again, momentum's conserved, so think about it in terms of conservation of momentum. So I jumped off the back of the skateboard and came to a stop. What does that mean? I lost momentum. I came to a stop, so I have 0 momentum because I'm not moving anymore. Where did all of my momentum go? The momentum went to my skateboard. If momentum of the system is conserved and I lose momentum, then my momentum had to go to the skateboard. So if I lose momentum, I come to a stop, then the skateboard is going to gain that momentum and it's going to go really fast. It's going to speed up, which is what you saw. The skateboard shot out in front of me. What is the momentum of the system at the end? It's still 10. At the beginning, the momentum of the system was 10. While me and the skateboard were riding together, it was 10. And after I jumped off and only the skateboard was moving, only the skateboard had momentum, the momentum of the system is still 10. So at the end, only the skateboard has momentum, and it has a momentum of 10. The momentum of the system is still 10. I have 0 momentum because I'm not moving. The skateboard has all the momentum at the end. And after I jump off of the board, well, I come to a stop, so my velocity is 0, so I have a momentum of 0. The skateboard gains all of the momentum. Because momentum of the system is conserved, because I have 0 momentum, the skateboard has all of the momentum, so the skateboard has a momentum of 10, and the total momentum of the system is 10 if I add those together.
So before I jumped onto the skateboard, while I was riding with the skateboard, and after I jumped off of the skateboard, because there were no outside forces on the system, the total momentum of the system stayed the same. It was always 10. Now the momentum of the individual components of the system changed, which is okay. So the momentum can go back and forth between me and the skateboard. It can go back and forth between different components of the system.
So momentum's kind of like money. Like if you and your best friend have $10 to split between the two of you, and you both promise not to spend any of it, so there will always be $10. So you could split it where you get all $10 and your friend gets none, if you're greedy, or you could split it as $7 and $3, or 5 and 5 if you're fair, or if you're feeling super nice, you could give them all $10. No matter how you split it, you still have $10 altogether.
So the momenta of the individual components of the system can change, but the total momentum of the system is always going to stay the same.
The momentum of the skateboard at the end is 10. Why is it moving so much faster than when I had a momentum of 10 at the very beginning? Remember, at the very beginning, I was the only object in the system that had momentum. I had a momentum of 10. And when I was moving, I was definitely not moving as fast as when the skateboard shot out in front of me at the end. Why is that? Well, it has to do with mass.
So the skateboard has the same momentum at the end that I had at the beginning. So at the beginning, when I had all the momentum of the system, I had a momentum of 10. And at the end, after I jump off, the skateboard has all the momentum, so the skateboard has a momentum of 10. So I had the same momentum at the beginning that the skateboard has at the end. However, the skateboard is moving much faster at the end than I was at the beginning, even though we had the same momentum. Why is that? Well, the reason is because I have a much bigger mass. If I have a ton of mass, I have to be traveling at a very small speed to get to the same momentum as the skateboard. The skateboard has a small, tiny mass compared to me, so it's going to have a very large velocity. It's going to move very fast in order to get to the same momentum. I have a bigger mass. I have to be traveling at less speed to get to the same momentum as the skateboard, which has a smaller mass. So it is going to be traveling at a much greater speed to get to that same momentum. So my mass accounts for most of my momentum, whereas for the skateboard, the velocity gives it most of the momentum.
If I'm just riding my skateboard, cruising on my skateboard, and I decide that I want to jump for joy and just jump up and down, is that a bad idea? So if I'm riding horizontally sideways on my skateboard and I decide to jump up and down, am I going to land on my skateboard, or is the skateboard going to shoot out somewhere from under me and I'm going to fall and die? What do you think? I'm going to try it. I'm going to jump straight up and down and we'll see what happens. Okay, so I didn't die. That's a good thing. So why did I not die? The key is that me and the skateboard are both moving together. Me and the skateboard are rolling together. We both are moving the same speed horizontally. So we both have horizontal momentum. When I jump vertically, I give myself vertical momentum, but that doesn't affect how I was moving horizontally. Giving myself vertical momentum doesn't affect my horizontal momentum. Before I jumped up and down, me and the skateboard were moving together horizontally. We both had horizontal momentum. Then when I jumped vertically upwards, I maintained my horizontal momentum. So when I jumped up, I was still moving with the same horizontal momentum that I was moving with before I jumped upwards. So if my vertical momentum changes, right, like when I jumped up and down, I gained vertical momentum. Vertical momentum has no effect on my horizontal momentum. So even though I jumped up and down, me and the skateboard still kept moving in that direction with the same horizontal momentum that we had, which is why I was still able to land on the skateboard. So horizontal and vertical momentum are separate things. If momentum in the vertical direction changes, that does not affect my horizontal momentum. So you can think about it like if you're riding in a car, right? If you're on the freeway going 60 miles an hour, you and everything inside the car is also going at 60 miles an hour. You're all moving together in the same direction with the same speed. So if you throw, I don't know, like a pen up in the air in the car, it's gonna go up and down and you can still catch it. Why is that? Because isn't the pen moving 60 miles an hour? Shouldn't the pen shoot out in front of you? Well, no, because you and the pen are both moving at 60 miles an hour. So if you're both moving 60 miles an hour, you both have that horizontal momentum. And throwing the pen upwards is only giving the pen vertical momentum, but it's going to keep moving with its horizontal momentum. It's still going to keep moving 60 miles an hour along with you, so you still catch the pen. Again, the vertical momentum I gave the pen has no effect on the horizontal momentum that it has.
Also, if you've been wondering about my knee, no,